In which case, the first person to talk is going to be Jérôme. I saw him joining, leaving, and then joining again.
Yeah, I'm there. Could you hear me?
I can hear you. I will stop presenting, and hopefully, with a bit of luck and a following wind, maybe you will be able to present.
That's nice. So let's go. Please tell me if you see my screen. You won't see my face, but I guess the screen is more interesting. So hello, everyone. I'm Jérôme Cornet. I'm the chair of the working group, which is responsible for the standardization of SystemC at IEEE level. And this is the and a very quick update of the 2023 revision. So first, a small disclaimer. I don't have much time, so I will go very fast. And please ask questions maybe later on if you want more details. So quick refresher. The SystemC for the norm, what it is both an implementation of the simulation kernel of some of the C++ classes you will use in your models. For this implementation, well, there are several possible implementations. You can design your own if you want. There's one that is provided as open source by Accellera. And then there are some commercial implementation as well from Cadence, Siemens, or Synopsys, for instance. And then we have tools as well that operate on SystemC, which is then considered as a kind of language in addition to being a simulation kernel. And for instance, synthesis tools, HLS tools, or tools that analyze codes to find, for instance, that you are maybe not following guidelines or not following proper good practices. And so the IEEE 1666, which is the name of the norm, is governing both the implementation and the tools. So these are the entities that contributed to the working group by reviewing every single contribution and providing feedback, discussing, etc. And so you have myself as chair and as Praveen Wadikar as vice chair and Mike Meredith as secretary. So in the past, there are two possible ways of contributing to IEEE norm. You can contribute at Accellera level, or you can contribute at IEEE level directly. This time, the main source of contribution was Accellera. The only source of contribution was Accellera, which collected all of the improvement and ideas that we had since 10 years on what we needed to do next for SystemC. And then the document you will see in the norm is a joint effort between Accellera and the IEEE working group. There are many things that have been touched upon in this standard. I will only focus very quickly on three of them. The relation with C++ standard, some productivity stuff, and I'll try to talk a little bit of about advanced features. So maybe one of the most important things is the fact that SystemC is based on C++. So there is a which C++ revision you are talking about. So recently, we can say the last 10 years, we have seen many evolution of C++ in itself. So we decided it was more than time to align and to try to clarify the situation. So basically, we decided that there was a new baseline that is guaranteed you will have it if you have a compliant implementation, and this is C++ 17. Why isn't it the latest and greatest revision? It's because, well, we have to align the whole SystemC ecosystem, and we cannot just say, yeah, please take the latest one and everyone will be happy. We need to take into account some industrial constraint as well. So this is to say that this is the minimum version you can count on when writing models, but for specific implementation and tools, they are free to support even more recent version of C++. Consequences is that you can write models using modern C++ code and practices, and we have begun, this is only a first step, there will be subsequent steps as well, to use that revision in the SystemC standard itself. Now let's move on to some productivity stuff. some example with some concrete code. Here is some code you would see in the old 2011 revision. If you use C++11 in your favorite implementation, you could write things like this. But then you have a usual problem that is, well, you could have a kind of an alignment between the instance name as it appears as an identifier in the code and the instance name as it appears in your favorite simulation tool. So the idea is that you always put the same name, or at least it's a good practice. So we decided to address this with a specific macro to do this. Obviously, macros are kind of wrong today, but this is the only way to achieve a consistent naming policy without effort. In this case, this is a good example of, well, we need to use macro to do the stuff. So this is what you would write in 2023. We do support as well the fact of passing additional constructor parameters directly when declaring a something inside the SystemC module. For instance, is you have the example of a signal where we pass an additional parameter. And speaking of parameters, so if you in the past, if you had a module with some additional parameters, you would write SC as process. You would have to use a special macro. Well, we removed that macro because it was only an artifact necessary for the implementation of SystemC. We managed to do without it. And we also we now provide a new SCCTOR macro that accepts also additional parameters. So it allows you to simplify even more your code when declaring the constructor. Now, if we take all of them together, you can use SCName, SCCTOR, and shorten your code. So good example of productivity improvement, small productivity improvement. Now let's move on with a different beast, which is STVector. So STVector, maybe as you remember, is a way to declare an array of things. These things can be ports, signals, instances of objects. So here we have an example of an array of signal. And so you would say, yeah, I've got an array with eight signals in it. And then, for instance, you would declare a sensitivity on each of the signals. That was in 2011. Now, what we can do is we can use a CNAME, obviously, but we can declare the sensitivity in one line. Small improvement, but still interesting. And actually, that sensitivity declaration is supporting everything that would support standard C++ std begin and end. So not only STVector, but even arrays of your own creation. And even array of pointers. Now, one of the limitations of STVector as well was that it was not possible to add elements once you had declared here the number of elements in your initialization list. So what we added in the norm was a new method that allows you to still in the constructor add new elements whenever you want programmatically, and that's called onPlaceBack with name, which is named by onPlaceBack, which is the new method in STVector that has been added in C++11. Here, this is onPlaceBack with name in the sense that we provide the name, but actually you could imagine also not providing the name and having the name automatically generated based on the index in the vector. And in that case, you just provide a potential additional constructor parameter. So wrap up, it's not possible to add an element to a vector within your constructor still. And after a first init, that's called onPlaceBack or onPlaceBack with name. And it's even possible actually to add new elements a little bit later. So there is a constructor parameter of STVector that allows you to add this new element even at before end elaboration, for instance. And in that case, you have to use that new constructor parameter that says exactly when the vector will be locked. Okay, let's move on then to advanced features. Two features covered here. first simulation stage callback. So these are the classical phases you will see in the SystemC simulation. Here, these are the elaboration phases. And here you can see what is happening in the simulation. I guess you are familiar with this diagram. And so you can see, for instance, here and there, and also here, that there are callbacks, which are methods you can implement, override, actually virtual methods that you will override in your SC module to be called at specific moments of the simulation. These are very classical and what we call phase callbacks. So these are used by the models for really the purpose of the implementation of the model, to instantiate new modules, to have delta notification, etc. What we identified very long ago, even during the 2011 revision, was the need for some other callbacks that are not for implementation, but that are for really observing the simulation. So there was a first attempt done, then Philip Hartmann, which is present here, did a second attempt quite a while ago. And the idea was really to access to some point in the simulation that were not previously observable. And really the idea was to observe and not to modify the simulation. So this led to a feature we call simulation stage callbacks. Basically, the stage callback that happen in between the phases. So you've got callbacks that are executed after, for instance, before end of elaboration, and start of simulation. And we have a new callback also executing after the update phase. And before, that's the pre-here, before we are about to advance the simulation time before running a new simulation cycle. And finally, we have a callback for also just before the end of the simulation. So these callbacks, they are not meant for implementation, so they are really meant for observing. So we identify the requirement that is they don't need to be located in a C module. You can write them in whatever C++ class you want. You just have that class to implement the SC stage callback interface class. And then you implement a virtual method to receive the information, the fact that we are entering that stage callback. The registration is quite similar to some other mechanism in SystemC. And we are also making this available for some other things I did not mention on the diagram, like before the simulator is about to enter pause or before it is about to enter the stop mode. So this was the stage callbacks. And then finally, quick word on suspension. So in 2011, we added a very important capability to SystemC, which was the capability to communicate with the external world, which means if you have you can fork a system thread here in a range, and then that thread is able to communicate with the SystemC simulation, which is represented here in blue, using this async request update mechanism, which says, hey, basically there is something is happening and I want the update phase to be called as soon as possible. So this is a very the basic mechanism to build everything. The classical issue many users encountered was basically sometimes the kernel has nothing to do. It's just waiting for that async request update thing to happen. And so you need to keep alive the simulation while you are waiting for the async request update. Otherwise, the simulation will just end and you are basically ruined. So the idea here is that, unfortunately, when you integrate models from different parties and that implement these keep alive mechanisms, they are not aware of each other and it tends to conflict with each other. So we needed a kind of standard here, which we implemented with the idea of suspension. So basically, the prim channel instances, the primitive channels, which were used for this mechanism, they can now opt for suspension in case of starvation, which means when they will be waiting for some event, they will opt in for suspension and call something called async attach suspending. And then when the kernel will starve, it will just be blocked internally waiting for an async request update to come from an external thread. So this is the idea, to prevent the simulation to exit and still have something that can be shared across many components, many primitive channels that are waiting for this type of events. It is also possible to do other things, like causing a suspension of the simulations from within the models. This is using new API, which are called SystemC all and SystemC all. And it's also, there are some nitty-gritty, it's possible to opt out for suspension, etc., etc. I'm finishing because I'm probably running out of time. Conclusion, maybe there is one question you are, I hope, asking from the very beginning of this presentation is, okay, when is this available? And the good news is it's available. It's available actually since last Friday. And so the norm is out. You can see it on the IEEE website. And we will soon make it available for free downloads using that Accellera link. So right now, it is possible that things are not completely in place. So normally, Accellera has signed an agreement with IEEE to ensure everyone can download the norm for free. Every norms that has been elaborated inside Accellera. This is, I would say, if you click on the PDF here, you will maybe not be able to download the thing right away. So please check whether it's okay. Maybe the best thing is to look for this URL here, which will be updated very soon with a direct link to the PDF file once it is available. And if for some reason there is some delay and you are really in a hurry, well, you can still buy the norm officially from IEEE, or even buy a printed norm if you prefer printed material. Conclusion. So I know this has been very quick, but this was just to show you that we managed to do things in very different domains. There are some domains that are quite small, quite minor, but that are essential for productivity. And there are some advanced features which are really aimed at communicating between the external world and the SystemC simulation. As you see in the federated simulation Mark was mentioning, we are now in a world where we need to establish communication between various simulators, and we need to communicate to form a kind of global digital twin. So we need this low-level feature to then build on them to implement these communication channels. Lesson learned. Well, we learned the hard way that you not only need commits, there was a quite long work to do to sort out what has been contributed over the years by the various implementers, by the various people. And well, we come back to the basics. Basically, an ideal contribution should really include not only a sample implementation, but also a rigorous specification, which is what we did during the elaboration of this norm. And I then take the opportunity here to thank all of the contributors, both from Accellera and from IEEE, which made this possible by trying to refine maybe the exact spec or to tune the corner cases, which were not necessarily, which are a bit overlooked at the beginning, into proper LRM element with proper text so that you can hopefully understand everything in this norm. Thank you very much.
Thank you, Jérôme, and thank you the whole IEEE group, because it's been a mammoth amount of effort. We're actually surprisingly slightly ahead of time. We definitely have time for questions if there are people who've got questions on the IEEE norm.
Don't be shy.
Yeah, don't be shy. No? Apparently the norm is so good that there are just no questions left.
Well, we are stuck on the download PDF link, maybe.
Yeah. Do we know when it's going to be downloadable from Accellera? Do we know that yet? Is it just it will happen fairly shortly, or do we know any more information about that?
Maybe we'll let Martin answer this one, since he's the Accellera guy.
Yes, Accellera is in contact with IEEE to get this standard under the so-called Get IEEE program. That is an Accellera-sponsored program for the design automation standards. So you find also IPXACT and other standards. This one is, of course, relatively new, right? It was released Friday. So the Accellera team is aligning with IEEE to make that available. So it's, I would say, a matter of days. Or perhaps even hours if we are lucky, but let's count for days that is not available. So we are working hard to make that available as soon as possible. As already said by Jérôme, the link on the Accellera site will directly guide you to the page where you can download. You still need to register. You should have an IEEE subscription, a personal subscription, but that is free of charge, so you don't need to be IEEE member. And if you have then that IEEE subscription and login, then you can download the standard. That's the only step you need to take. But from the Accellera page, we will directly guide you to the right IEEE page, because there are different places. There is the IEEE Explore, there is the Standard Association. So to give a direct pointer where to download, we make that available. So in that sense, follow this IEEE Accellera page where this standard is listed, as well as other Accellera originated standards.
And then I suppose the other question that everybody would love answered is when can we download the proof of concept simulator to try all of these new features out? And I think
I think there is one additional question I can say as a neutral working group chair is also when will the EDA vendors version commercial implementation will be available. So this is surely not today or even tomorrow, but we need normally a little bit of time before the guys completely fine-tune their work. My hope is that we can come with a kind of announcement by the end of the year, for the SystemC Evolution Day maybe, to see what will be the status and whether your favorite EDA vendor is very quick at adopting this revision, and obviously also the Accellera proof of concept implementation as well.
Absolutely. And you can rest assured that obviously the proof of concept implementation is not going to take that long to produce, because most of the features that have been discussed here have been proved in their concept, in the proof of concept internally to Accellera. So hopefully that will come out fairly shortly.
Yep, exactly.
Are there any other questions from anybody? In which case,
maybe I will then stop sharing and hand it back to you, for the next speaker.
Indeed.